As usual, it's good to start at 3 or 4 past, just to give time to people to join.
Yeah, makes sense.
And that's right, Karsten. It's exactly the same file, just for reproducibility.
You mean it looks strange with the
fonts,
in the
especially
letters.
on the name of Jaime.
Yeah, I wonder, and your name also. Yeah, I wonder why it's like that.
We reported that to Miteco already, so I think they are looking into that. But
it's something newly introduced, as it looks like. Yeah.
So I know Christian is in a car for a few more minutes. And Joran will also join a little later, he told me, but I think we can start in a couple of minutes. Yes, thanks for the links to the minutes. I'll try to take notes, except for the presentation I plan to run. Any help is very appreciated.
Took 10 seconds for the chat message to turn up in Jabber.
Ah. Thanks, Richard. Okay, I think we should start, and we'll consume a few minutes of the introduction anyway. So welcome everyone to this interim meeting of the core working group. I'm Marco Tiolka, my co-chairs are Jaime Jimenez and Karsten Gorman. This is an official IETF meeting, we've been recorded, and the note well applies. It's not just about IPR, it's also and especially about our code of conduct, so be nice and professional to each other. And today we have a relatively packed agenda compared to usual interim meetings. We are supposed to start with a number of open points to discuss about the kudos draft on key update for OSCORE. And then we have a point that we can really discuss with Michael Richardson, especially only between 1440 and 15 UTC, if he actually manages to show up from another conflicting meeting. Then we also have the OSCORE capable proxies document that I plan to give an update about. And then we have also co-op over GATT from Christian. If we see Michael doesn't show up at the expected time, perhaps we can pull up co-op over GATT, actually. What do you think, Karsten? Sorry?
Did you just address me?
Yeah, I was asking if the possible agenda bashing to be flexible with Michael would work.
Yeah, so he sent another message that he also had some misunderstanding of the train schedules and so on. So he will turn up at some point in this hour, and then we'll just do that item, I think.
All right. Great. That said, I think we can get into kudos then.
Yeah, sounds great. Let me try to share the slides. Yes.
There you are.
Okay. Yes. So hello to everyone. So today I would like to present here some updates to the key update for OSCORE Kudos draft. And I'll start with a short recap. And as you may know, this draft mainly contains two, let's say, parts. One related to the actual Kudos procedure, which is a lightweight way to renew the OSCORE Master Secret and Master Assault. And also a part about the AED key usage limits specific to OSCORE, defining appropriate values in terms of number of decryptions and number of encryptions, and how you can extend the OSCORE context to take into account the counting and the limits. But today's main focus will mainly be Kudos. There's one point about the limits also. So going to the next slide. This is a general recap of the Kudos for King procedure. So the fundamental idea basically is you have a message exchange where you exchange nonces, N1 and N2, and these are fed into a update CTX function that internally produces a new OSCORE Master Secret and Master Assault. And after the procedure is finished, the peers can continue communicating with this new context. And part of this procedure is relying on an extension of the OSCORE option. So we extended it with a nonce section and a byte before the nonce, which defines the length of the nonce, and also some additional signaling bytes that we have defined to keep observations or not, and whether to use the forward secrecy mode or not. And as you can see in this figure here in the bottom left. But now I want to go into the open points for today, and these are the ones we have listed. I'll go through them in more detail later on, but basically it's about these. The first one is about the flag bits in those corruption and some considerations on those. Then we talk about a single method for updating the key material that's related to this update CTX function. Next is whether or not we should have a negotiation for the forward secrecy mode or not. Then it's related to the content about the key usage limits and possibly relocating that. Next, it's about extending ad hoc with EAD items for Kudos, so peers can learn through an ad hoc execution whether other party supports Kudos or not. The last point is where and how we should define the content about updating OSCORE sender and recipient IDs, which is also currently a part of this draft. So yeah, to start going into a bit more detail. So the first point is about the OSCORE flag bits. So there's been some discussion on the mailing list about this. You can see in reference number 1 there. But basically what has happened is, first of all, our D bit, which is the bit that indicates that this is a Kudos message and that the nonce component is present, has been registered now. As for other things, basically the current situation, and this is about the actual OSCORE flag bits, the current situation there is that bits 0 and 1 are reserved from the OSCORE RFC. And the current text in Kudos is that we say that we should define bit 1 for signaling a second flag byte. So it's an extension bit for the OSCORE flag byte. Basically, you're saying, okay, I want a second flag byte. And and as you can see, the D bit is then present in this second flag byte. However, there's been a discussion on the mailing list about an alternative approach where we want to instead define bit 0 for signaling a second flag byte. And then we can change bit 1 to unassigned. And yeah, sorry, I saw the text became on top of each other there. But the point is that this document is already updating the OSCORE RFC. So these points can then be a part of that update as further elements that are to be updated. And the thing here is that the bit 0, there's not a concrete plan for using bit 0. It's only earlier considerations about possibly using it for an uncompressed COSI object. But it seems that that is not, that was more an old plan, which is not presently considered. And the nice thing about using bit 0 for extension is that it's a consistent pattern, and you have that, let's say, leftmost bit. So you can have bit 0 for having, the next byte, and then in that bit 8 indicates to have yet another byte, and then it's byte 16. So you see that it's a pretty nice pattern like that. So, so this alternative approach, basically, the question there if that is a reasonable way to take. And in such case, what we would do then is to do possibly do an early allocation of bit 0 to say that this is for defining the signaling of a second flag byte. And we can then change bit 1 to unassigned for possible future use. And we may, in addition to that, already register bit 8, 16, 24, etc. As extension bits to indicate that you want one more byte apart from what you already have. So that's the question. Should we switch to this alternative approach from our current approach? And yeah, we feel it has a number of advantages in doing so. See a comment pop up in the chat, and I see Göran also. Yeah, I see +1 from Karsten there in the chat. And Göran is in the queue.
Yeah, sorry, I came late here, but I think this is a good proposal. I don't think we need to allocate in advance. We could take a byte at a time, or maybe the next byte or so. But yeah, but I think this is a good approach. And the interesting thing here is that the person that proposed, I think the person that proposed the previous use of 0-bit is the same person as now is proposing the other way of using it. So yeah, I think that's there should be no one that's not heard here in this question. But there might be others. Yeah, unless there's anyone else having a comment.
Of course, and if anyone has, of course, feel free to then. This is also a discussion on the mailing list, so people can jump in there if they have a concern. So you should, of course, check more that there are no further comments. But okay, it sounds like you agree with this approach, at least, yes.
Göran, to be sure, you were suggesting to not rush with registering bits 8, 16, 24, right?
So I didn't see the reason to register this. I mean, you can register for 0 and bit and 8 because those are the ones that we have plans for. The other bytes are really
I see. Okay. So
are theoretical at this point. So when you start registering things in the third byte, then I think you can allocate 16. But this is not a big thing either. I think this is a good approach. Just go ahead.
Sounds cool. Then sure, the let's say fine details and on how we do with bit 8 and 16 and such we can think about a bit more. Yes. Karsten says in the chat he'd prefer to earmark bit n times 8, I guess, every 8 bit. Yeah.
That is fine by me too, if you want to do that. That's okay. I don't have a strong view here.
I see. Okay. Well, thanks for the feedback on this point. I'll jump to the next one then. So yeah, this was another point I believe triggered by some discussions and also an issue that was created on this. So the point here is that currently in the update CTX function, which actually practically updates the OSCORE context, so you feed it the nonce essentially, or the nonces, and it produces a new master secret and master salt. But the point is that currently we have two internal code paths it can take. One is using the add key update, which you see is method 1 in the green box. That can be used if the original context was established using ad hoc. So you have the add key update available. The other path is that you base the update on an HKDF extract and expand, and you see in the blue box, and that is intended to be used when ad hoc was not used to generate the context for the initial context. So the point there is that, well, method 1, first of all, assumes and requires that you have a valid ad hoc context or session available, because otherwise you can't use the ad hoc key update. And it may also be the case that you need a kind of fallback that, okay, what if the peers originally used ad hoc, but okay, the ad hoc session somehow became invalid, so you wish to use the HKDF extract and expand method rather than the ad hoc key update. So you may need a fallback or even some kind of negotiation in that case. So basically, the feedback from IETF 114 was, and our idea then was to, okay, but why not, only use method 2? So we actually removed the ad hoc key update path, and we only rely on the HKDF extract and expand. And it seems that just like using the ad hoc key update, it doesn't provide any additional benefits over only relying on the HKDF extract and expand. And it also has some good properties in terms of building this XN value, which we can simplify building, because the ad hoc key update requires that it's a CBOR byte string, but if we use the HKDF extract and expand, we no longer have such a requirement, so it simplifies things. So yeah, to summarize, the proposed change here is to update this update CTX method to remove method 1 and only use method 2, only use the HKDF extract and expand method. And that's a simplification, and it seems there's no drawbacks in terms of security. So that's the question. Are there any objections to this idea? It seems not. Well, I see Karsten is jumping in.
So how do we check that there are no changes in the security characteristics?
Yeah, I guess that's I think we discussed it briefly during IETF 114. I guess the question is fundamentally like, are there any security benefits you get from the ad hoc key update that you do not get from the HKDF extract and expand? And from our reasoning and discussions, we have not been able to identify that there should be any specific benefits for using ad hoc key update compared to the HKDF extract and expand. So I don't know how to if we, let's say, formally prove that, but from what we have discussed and thought about, we could not see any drawback in simplifying this to only use the method 2. But that's also why we ask for feedback here. If anyone has an idea or why this would be not good, or why it's preferable to keep both methods around. I see Göran and Marco there. Yeah.
Yeah, just a short comment. The construction in method 2, by the way, mimics the same construction of key update of TLS.
Yeah, good point. Yeah, that inspired from there exactly. Yeah, same design.
Yeah, I try to think here. So what key update does is iterate, it's sort of an iteration with the hash function, based on it's taking the random key comes out of ad hoc and it iterates, hashes that, and then you derive from that the OSCORE master secret, and this is just doing the iteration to the master secret, and I don't see any difference from my side.
Right, that's also what we concluded, that fundamentally you, regardless, you end up building a brand new master secret and master salt,
and with the same type of method. So yeah,
it's similar in that, right? Yeah.
The only thing I thought about was that if you're using OSCORE with some other key derivation function, you are now locking this to HKDF, which everything else in the default values for OSCORE is HKDF. But for ad hoc, we have a little bit more agility when we sort of, you may use KMac or you may use some other.
Yeah, I see what you're saying. I guess like in this case, this update CTX procedure will be unique for kudos, and the way we have it defined now, then sure you would lock it to only allowing the HKDF extract and expand way. So that's true. Then I don't know if it's worth having. You could have flexibility there, I suppose, but then it comes down to how do the parties synchronize on which.
Yeah, no, I don't think there is any need for that. I mean, let's not do that now. Let's stick to this as we have HKDF already as a default in OSCORE.
Sure. Yeah, but I think it's a good point. I think that you mentioned. Yeah, I see there's some extra feedback there in the chat from Christian on the previous point. But fair enough. Then it seems there's no strong objections from what I can tell to proceeding in this way. And of course, we can have an extra round of thinking about if this really that we're really sure about this thing about the security properties. Let me move on. So this was a point raised based on an issue that Christian created. So the question here is essentially currently kudos can operate in two modes, one with forward secrecy and one without. And the reason for that is that some devices may be very constrained and unable to store write information to a disk, which means that if they reboot, they lose any master secret that has been generated from kudos. So they basically have to revert back to some kind of bootstrap master secret. So the point of having this no forward secrecy mode is to allow such devices to actually use kudos. Because if you want the forward secrecy mode, you have to be able to remember and write to disk the intermediate master secrets that you generate. And currently we have some signaling for this in this P bit, as you can see in the figure on the right-hand side. And essentially you can set the P bit to 0 if you want to use kudos in forward secrecy mode, and 1 if you want to use it in no forward secrecy mode. And the point is that both pairs have to agree. So both have to have either 0, 0 or 1, 1. So they match, they agree on which path to take, right? But the point is that there is the case where, let's say the initiator says P0, so it wants to use kudos with forward secrecy. However, the responder is not capable of that because, for instance, it's a very constrained device which cannot save to disk. Well, then the initiator can simply respond with P1, and then the actual procedure can be aborted, and the initiator can rerun kudos, but now with P0. So now you run in with a no forward secrecy mode. And the point there is that, of course, this is all. It's a potential also a learning procedure that after you have at one time run kudos with the other pair, you can learn about these capabilities. But it's not a certainty that you know ahead of time if the other pair supports the FS mode or not. So the question here basically, and the issue Christian raised is like, can we make an assumption or can we require that the devices know ahead of time whether the other pair supports the FS mode or not? Because in such case, there would be no need for the negotiation at all, right? You simply know what the other party supports, and that's what you go for. So we thought about that. I mean, the thing is, the question though is that does OSCORE security context have this information about whether other peers support kudos? And if yes, does it have the information regarding if it supports the FS mode or not? So I believe the answer there is really maybe, because the point is that the way we do it now, we don't require that. We don't require that they have this pre-knowledge. So the solution is flexible. So it would work also in a scenario where you don't have the pre-knowledge. And if we want to mandate that they have to have pre-knowledge whether other party supports the FS mode or not, then we have to make sure that in all cases where kudos is used, they have this information in the score security context, which may not always be possible. For instance, if you use the score ACE profile, there may be no way to convey this so that both parties know what the other one is capable of. So if we make this requirement that they must know, we may limit the usability or add this extra requirement of pre-knowledge that may be hard to fulfill. Yeah, Christian, I see is in there.
I think the ACE OSCAR profile is a good example of why this information would be available, because the authorization server, which picks a secret that would be shared between the peers, has to know already which algorithms those peers support. And whether or not you support forward secrecy mode is an information that is very similar to the information about the algorithms. And that information already has to be with the authorization server.
And in addition, within the token itself, I believe, so that may add complications in terms of having to change the OSCAR ACE profile. Yeah, I see in the chat, Christian says my sound is a bit choppy.
Yes. I also got, but it's better now.
Okay, it's better now. Let me try. Sometimes it helps here if I disconnect from the wireless network. I don't know why it would prefer that, but sometimes it does. So hopefully it will be better now. If not, I can repeat things. But yeah, so to repeat what I said, basically having this requirement may mean that we have to extend OSCAR ACE profile, because there must be a way to convey this information to both peers, which means putting this in the response from the AES and also putting this information within the token itself. And there's no appropriate fields where to do that currently, right? So it may add complications in terms of having to update OSCAR ACE profile.
And how if this is combined with OSCAR ACE profile, how would the parties know that they can do kudos in the first place?
They would, I mean, today they wouldn't, but I think that's one of the strengths of the way we design kudos right now, is that it's not necessary that you know if the other peer supports kudos or not, and it's not necessary to know in which mode the other peer supports, because you can actually, for kudos, you can simply try to initiate kudos. And as far as the mode, well, we have this, let's call it a basic negotiation to synchronize on the mode. So today you wouldn't know, but you don't need to know.
Okay, yeah. If it's completely just try, and if it doesn't work, you can still fall back. Then at least negotiating in the sense of trying to do forward secrecy mode, and if the other says that no, sorry, can't do that, falling back, sounds not too bad.
No, I think right. So that's the strong suit of the current solution. And also, of course, if you do have pre-knowledge somehow, you can take advantage of that and immediately go for the mode that you know the other party supports. I see both Joran and Karsten there in the queue.
Yeah, okay. I don't know if I'm first. I can start anyway. So I think the trial and error is good enough for unless I don't see any reason why this needs to be known beforehand, really. But please enlighten me on that. And the important thing here is that the negotiation is secured, but that you've talked about already.
It is, because the actual these flag bits that you see where the p bit is the X byte where the p bit is present, that will actually act as input also to the key to the update CTX function. So it is integrity protected due to that. As far as your point, yeah, the pre-knowledge is today is not required, but if we put it as required, okay, the simplification is we can remove the negotiation, but yeah, the downside is we lose some flexibility, and then we have to enforce the fact that they have to know in all situations, whether it's with ad hoc, whether it's hard-coded context, whether it's those correct profile.
Yeah, I think could I ask just to wrap up. So I think thank you, and I think that it's good if we don't add more things that you need to configure beforehand. It's good if things can be discovered, because that will mean we will need to update all these documents containing various information bits, and the protocol becomes more complicated and so on. So I'd like to keep it separate if possible.
Okay, I see. Thanks for the input. I see Karsten also in the queue.
Yeah, I just wanted to make the general deployability point that by requiring some other components to also move with you, you make it harder to actually start using CUDAs. So I think I agree with Göran here that we should reduce potential interactions, dependencies here to make sure that people actually can start using CUDAs as soon as possible. But my question would just be, you say CUDAs is aborted if the pbits do not agree. I assume the code already has to be there to handle an abort, right? There are other cases when CUDAs cannot go on, or is this the first one?
That's a good point. I think probably, I mean, okay, so if one side doesn't support kudos at all, of course, it will be aborted in a sense. But I believe that currently the only way it can be aborted in this sense of the word is this case where the p-bits do not match. That's, I believe, the only case now where you actually have an abortion happening. Yeah, otherwise it will be okay. One side supports kudos, the other is not even aware and has no kudos related code. So
essentially, the one who wants to use the feature pays for the code, which is essentially the right way to introduce new features.
Yeah, so I guess that was, I suppose, also a point from Christian that removing this negotiation also has a potential benefit of reducing the number of code paths and code complexity in a sense. So that could be put as a pro on the side of requiring pre-knowledge and pre-configuration. But thanks a lot for the feedback on this point. I'll try to continue and maybe speed up a bit then if 4:40 is the time and deadline in a sense. So this is about another point here about splitting out the context related to update of OSCORE IDs, because currently we have one section that is about a procedure for updating the OSCORE sender and recipient IDs. Based on earlier mailing list discussion and also an OSCORE issue, and this can be related to privacy, for instance, where you want to switch IDs to not be trackable across different networks. Currently, this procedure can be run completely standalone. It can also be run as part and integrated within a kudos execution. And yeah, it can be initiated by either server or client. It's a fairly simple way. You have a new co-op option where you propose a recipient ID. And of course, you have to follow certain rules in what recipient that you pick, that it is free, etc. And both pairs have to agree and use this option to opt in to say that, yes, we want to update our IDs. And of course, changing IDs will practically trigger a derivation of a new OSCORE security context. So you have new sender recipient keys that you will be using. So the question here is, from feedback from IETF-114, should we split this out into a separate draft? This is not directly related to kudos. It is, however, directly related to OSCORE. But if we split this out, the kudos draft will be more focused on kudos, and this is a independent procedure for only updating OSCORE sender and recipient IDs. So that was one thing brought up during the previous IETF meeting, that, okay, what about actually splitting out this functionality to have, let's say, more, but shorter or less complex drafts. So that's the question here: is there any strong feeling whether we should split this out or keep it in its current position within this kudos draft?
Yeah, I think I already stated my case at the IETF 114 that I think we should.
You think we should, right? I recall, yeah, it was you who had brought up this point during the previous meeting. Yeah, it has its advantages, of course, in terms of making the draft more focused on the core content, which is kudos and the limits. And this can be used, possibly someone would be only interested in this procedure, the updating procedure, and not actually kudos. But okay, thanks for the input. And of course, any further?
Yeah, Christian, Karsten, what do you think about the split? We're not too many people, so it's good to hear from the few ones that we are.
I don't have any clear preference. Whatever works better for the authors.
Okay,
Thank you.
thank you.
Generally, a split is what you want to have if you expect different groups of people to review something. So that's a strong argument for a split. I'm not sure this is the case here.
Maybe not necessarily. I would say that it would be different people reviewing it. I guess it will be similar group of people regard, I would say.
I think the argument appeared in the context of size of specification and how many. I mean, we looked at two drafts, and we said that maybe we can split out functionality to make them more focused.
I think that was the main argument to have. It's better, like it's a trade-off, but then the argument was it's better to have more drafts, but that are less complex and shorter and more focused compared to fewer, bigger, with more content, right? I think that was the main argument, yeah.
So what is the size of this feature?
The size in terms of length, let me check here. It's a bit hard to estimate. I can't see the page number where I'm looking now, but it's yeah, let me have a look in the text version. I can see how long it is, how many pages it is. Yeah, you have it there. Yeah, so it's okay. It's basically let's say six pages of content.
Does that include examples, or is that without examples?
Early versions of examples to be certainly improved, but the core mechanics should all be there.
So the examples there, they may grow a bit because of comments, but it's it has basic examples, so it's six pages currently out of 15 total with appendixes. So let's say 10%.
Yeah, I cannot really derive a strong benefit of separating it out from those 6 pages, but it's also large enough that it's at least worth considering. So I think I'm pretty much neutral on this.
Okay, I see. Yeah, it's not super short to the sense where it would be strange to have a draft only about this. I would agree. Yeah.
I think the main point we discussed was the key limits, which is also in this draft.
That is
so also, we noted.
Yes, that's actually coming up also as a further point, if you mean about relocating that content.
Yeah, so we have key limits, we have kudos, and we have these identifiers. And sort of based on focusing on kudos, I think the proposal from my side was that we take out everything that's not kudos, which will then have an impact on the kudos size, but there will be
more
smaller documents.
Yes. So yeah, right. So I can maybe jump into the next one here. Actually, let me jump ahead a little bit. So this was the point about, so essentially you could argue that the draft has 3 main parts now, which is kudos, the limits part, and the OSCOR ID update. So one path is we keep them all in the current draft. Another path is we split into 2 new drafts. So we have kudos and the limits, we have the update, so 2 drafts. The other path is we have 3 drafts. So we have kudos only, the limits related things, and then the OSCORE ID updating things. So there's actually multiple options there in terms of if we're talking about splitting the draft into multiple. As far as the content about the limits, there are, let's say, sub options there on what to do with it. So currently the limits really focus on 3 things. One is an overview of the limits, calculations with recommended values to use, building on the C4G draft. The other part is how do you extend the OSCORE context in terms of limit and counter objects in there. And you have this X parameter where you actually can define a lifetime of the OSCORE context. And the third part there is extending the OSCORE message processing. So practically when you encrypt a message, you want to increment a certain counter. Yeah, and also tell me if we should put kudos on hold to move to the other document. I know there had a limited time slot. But just to finish this page, there's 3 options here in terms of what to do with the limits. One is keep it as is. Second, move some parts related to the limits to the appendix. Third, move to a completely new draft. So in general, it's one part is about splitting the draft. Do we have 1, do we have 2, do we have 3? The other part is, okay, as far as the limits specifically, what do we do with that? Then there's also options, keep as is, move to a new draft, or like a middle ground, which is to move to an appendix. But I think your point was you would prefer to even split this into 3 separate drafts.
Yes,
that's
my proposal.
So that's this one option, and exactly right. So then it's more focused. You have the limits and the OSCORE processing related to the limits. You have kudos. You have the OSCORE ID update. 3 shorter but more focused drafts then, yes.
And just agreeing with Karsten here that the limits is the one that should go out, and the identifiers is not that important.
Yeah, just to be fair on the way we got to this point, the very original plan was to have 1 document on the limits and 1 on kudos. And at some point at that interim meeting quoted there, John had a very strong opinion about having a single document instead of both. So we can take it back and go the other way, but just for the record to document how we got where we are.
Sure. This was from an interim back in April of 2021 where this was brought up, and then it was kind of the consensus was to keep it in 1 document. But
okay, so should we move to Michael's point?
Yeah,
I think so. 1 slide was skipped, but that can even go on the mailing list, and it's
can go on, yes,
super urgent anyway.
It's registering ad hoc EAD items to signal kudos support, basically. But yeah, let me that can be on the mailing list, and you can check the slides. They're uploaded also to the meeting materials. So. But thanks a lot for all the feedback, and then I will end my sharing now.
Thank you. Michael, welcome. Do you want to drive this lot? And there's a few useful pointers in the notes, actually. Yes. I think it was mostly to continue and hopefully wrap up the discussion that you and Christian especially had on the mailing list. Oh. Okay. Christian, do you want to add anything on top of what you said on the mailing list about this?
I don't have anything particular to add right now, also because I haven't managed to follow up on all the latest responses I got. But I'm afraid yes, then we'll move this to the list again.
Yeah, to me it seemed that the discussion we were having was actually useful in that it seemed to uncover at least a new way of looking at the things that Anima is actually doing there. And I'm not sure that this thinking process is completed at this point in time. So I'm not having any well-considered opinions because I'm still trying to digest the changes in perception of what the Anima points actually are. But I still want to make sure that we are not the people who are holding up the Anima document. So we should try to be as helpful as possible.
Right, perhaps a dedicated design team meeting would help with people from Anima and Core. Right, if it cannot happen right here, right now, there'll be another way to discuss. If it doesn't continue on the mailing list spontaneously anyway. What do you think, Karsten? And Michael, if you can type.
Yeah, I think having a design team meeting would be good. I was hoping to use today's interim for that, but maybe we don't have the right circumstances here.
Right. Okay, Michael says we need some core person to express a specific view on how to deal, and Anima will do whatever you say is best. And design team meeting is good.
Yeah, I think the most important person here is Christian, who just said he has a hard time picking a slot.
Yeah.
Yep. Let's try to come up with something in mail exchanges to get a concrete proposal, and then see whether we still need a design team meeting.
Okay, where do these mail exchanges happen?
Right now, I think it's a big thread that is shared between Core and Anima. It might make sense while we nail down what becomes like, quote unquote, the core opinion, to limit the recipients to basically Core, and then take the rest of the recipients up again.
The thread is linked in the notes, by the way, on top of this agenda item.
Okay, thank you.
Since we saved some time out of this, should we get back to Rickard that skip slide and wrap up the presentation?
I could show that one. It should be pretty quick, yes, if we have the time.
To wrap up on the last point discussed, by the way, is there a preference to really have 3 separate documents on the 3 different things?
Yeah, because I would also say that one option is, of course, to split. So we split out the limits, but we keep the ID update and kudos in one draft. That's also another option.
Yeah, at least Göran had a clear preference for 3 documents.
Yes, and yeah, indeed, yeah.
So, okay, if I can add here, I think that when we talked about this in the meeting, it seemed like pretty clear that we wanted to reduce. We were actually discussing some other draft first, and then discuss this draft, and then we thought this was a good idea in reducing the sizes and the scope of the document. Now, when we discuss this now, people seem not equally convinced that this is the right way to go. So maybe we should just wait a little before doing this and keep things in one draft until we really understood what we want to go.
Yeah, we could wait. I mean, what I heard was more, let's say, more enthusiasm for splitting out the limits, the ID, then people will more neutral, let's say. Karsten, I see in the queue, yeah.
Yeah, I'm just wondering which part has the agility here. So the limits discussion can by its nature not be crypto agile. It's talking about specific algorithms, right?
Yes, yes, exactly.
So
It's specific.
it would need to be updated each time we pull in new algorithms and so on. So it's kind of a different style of document than the protocol documents, which are agile by their nature. So it may make sense to separate the documents just from that point of view, that it's easier to update the limits discussion if we don't have to update the protocol documents and vice versa.
I see your point, right? Because sure, if there are some new algorithms coming, then they may have then specific limits, because like you said, the limits document is talking about concrete specific algorithms with lists of individual algorithms. Yes.
To add to that, I think that the limits discussion is not concluded, and we don't really know what the conclusion will be. We are referencing the CFRD draft has not passed working group last call, and
right.
I expect there will be further discussion on that before that's finished. So that's also a good thing to separate out for that reason.
Right, that's true. We need to follow that CFRD document, and of course there may be updates there that end up happening. Then we should follow along with updated formulas or otherwise. Yes. True. So then there are then those two benefits of splitting out the limits part. Yes.
So we would have an informative reference from the key update document to the limits document.
Yeah, I mean, I guess like the limits, basically the limits are like, if you reach those limits, you should rekey, but then practically there are different ways of rekeying. You can run eddoc, and one way is then kudos.
Yes.
But that is one way of multiple in a sense. Yeah.
While about splitting on the Oscar IDs, we can just wait a bit. Maybe raise it again at the next round.
Right. So yes. So right to exactly. So that is my feeling too. That splitting out the limits is less controversial. Let's say people agree more with that, and the IDs can. Let's keep that within the kudos main document for now. That makes sense. Yeah. But yeah. So of course, just feel free to give any further feedback on the mailing list or otherwise. I will go to this last point then. So this is about introducing ad hoc EAD items for signaling kudos support. So the point there is that we could register an EAD item in ad hoc that is used for signaling whether other peer supports kudos or not. And essentially, the benefit here is that a peer will learn if the other peer supports kudos and which modes during ad hoc execution. And we have an idea of a semantic here, so you could rely on 4 different values, basically. One, to simply say that, okay, I want you, the other peer, to tell me what you support. Other value would be, well, I don't support kudos. Third one would be, I support kudos in both modes, and also asking the other peer to indicate what it supports. And the fourth value would be, okay, I support kudos, but only in the no FS mode, and also to indicate to the other peer to say what it supports if it have not already done so. So it has the benefit of being able to, via an ad hoc execution, you can exchange this information so both peers would know what the other party supports, and there's no ambiguity. So the question here is, should this be done or not? I saw Christian had a comment also in the chat earlier related to this point. Can I find it now? It was, I think he was saying, split. It's a bit moot because the conclusion before was that kudos works well in opt-in mode. So sure, this functionality is not strictly speaking necessary, because within kudos you do have this negotiation or simple negotiation to learn this regardless, and you can do a trial and error attempt to run kudos. It may still be nice though to be able to exchange this information through an ad hoc execution, so that because you can take advantage of the fact that you do know what the other party supports, and just go straight for that without any risk or chance that there will be a mismatch. So yeah, it basically would be about registering an ED item in ad hoc.
So my thoughts here, yeah, thanks. My thoughts here are, if we're going to do this, I think that Christian's point is good. So now we're really going in we started a train of thought here, and we're going in that direction, and that makes sense. So that kudos already can be opt-in. So that's nice. The other extreme is that we have an EAD item which is actually not only telling you whether you support kudos, but also whether you will use ad hoc key update, which we already sort of taken out now.
That's true. There could be, I mean, that's also something we were thinking about in terms of the ad hoc key update. If we wanted to keep that around, it would need some kind of signaling, either within an EAD item, or maybe even actually signaling within the within the kudos execution itself, because you may need to, on some kudos executions, can you use ad hoc key update, but in others you can't, right? So having even an EAD item may not be sufficient in that sense.
Okay, right? So that's a good point. My main concern now that we've taken out ad hoc key update from the kudos execution is actually, how are we going to invoke ad hoc key update? I mean, we have specified the function, but we haven't specified how it's used. That might be a problem for ad hoc rather than for OSCORE, but it's still something. If we currently don't have any pointer to how to invoke it. We had that before we took it out today.
I see what you're saying. So that's more general, like to have a practical example on how to invoke it. Yeah, sure. If we take that out, there won't be such an example in kudos, and kudos will no longer use it. So perhaps that would have to be placed within the ad hoc document itself in such case.
I just wanted to remind the reason why we started to think about removing method 1, actually. The fact that both peers support it by learning about that in advance or by trial and error is not sufficient to actually run that method based on ad hoc key update. The ad hoc session established back then also still has to be valid. Whatever valid really means, that has to be defined
exactly.
in the ad hoc document, I think. If that's not the case, then the peers have to go also in this case for an agreed fallback. And that's where we started to think, okay, but if method 2 would always work then, and is not worse in terms of security, why not keeping method 2 alone anyway? And that's when we started to think, okay, maybe we can forget about method 1.
Yeah, practically, I think if we keep both, we would have to have one more flag bit to signal whether to use method 1 or 2, because it has to be dynamic per kudos execution. Göran, you want to jump in?
No, I'm just thinking, so I'll turn off my microphone. I actually don't have a good view here. I need to think more.
But yeah, the point, like Marco said, if this is like a pure simplification and we remove the ad hoc key update without loss of any, with having the same functionality with ad hoc, with the HKDF extract and expand, and loss of security properties, then it's simplification in terms of code, and avoiding this negotiation thing we probably have to introduce if we keep both methods. That was the logic, yeah. And yeah, probably again, like having an ED item for that it's not enough, because it doesn't help if you know. It's not enough just to know it once. You have to be able to decide for every execution, because what if your ad hoc session became invalid due to for some reason, like some certificate expire or other reasons, then practically you shouldn't use header key updates. You need to be able to signal for each QoS execution whether you want to use header key update or the HKDF variant. Yeah, but to summarize this final point, this again, the question here is, yeah, should we register this ED item in EDOC? And again, it's not a necessity for kudos to function. It is though nice to have because it helps the peers learn about this ahead of time. And again, then they know for sure 100%, and they never have to. There will never be a mismatch, so they have to retry or such. It's just clear from the start. Yeah, something to.
Yeah, just to add to what Rickard said, this is not strictly speaking needed to enable anyway. The rationale was just that if the two peers are running EDOC anyway, this is a cheap way to learn things that spare them for further logic later on. That's it.
It's a cheap way, and it's using, let's say, built-in functionality of EDOC via the EAD, right? Yeah, that was the logic behind it, essentially. But okay, that was it. So yeah, if there are no last comments, I think that's about it for this presentation. So thanks a lot for the good discussion and feedback.
Thank you, Rickard.
Thank you.
So I take next one. Right. This is an update on the OSCOR-capable proxies document, and last time we saw that presented was in November last year at IETF 112, and that was version 01. So quite a few things happened since then. I try to summarize here. Just to give some recap, this is about considering scenarios where you have a proxy between a client and the server, and you may have, and there are a number of use cases also described in the draft, the need for a security association between the client and the proxy, typically, but in general with the proxy. And it would be nice if that secure association is based on OSCOR, especially, but not only, if you are already using OSCOR end-to-end with the origin server. So this is a territory not really considered in the OSCOR RFC that actually explicitly forbids a number of things that would come up here, especially protecting a message with OSCOR multiple times. We actually started the work in this direction as an appendix of another document, GroupCom proxy, that in fact ended up being the first use case where this could make sense. But then it was discussed a few times and agreed that it was much better to develop this particular point independently on a separate document. And just to recall the main use case we've had in mind, but there are more in the drafts. One was indeed GroupCom proxy, where you have a proxy taking a request from a client and is supposed to identify the client through a secure association before forwarding that request to a group of servers. There's a similar use case related to group communication, where the server sends back notifications over multicast. And if there is a proxy and group OSCOR is used end-to-end, then the clients are supposed to take an additional step and instruct the proxy on how to practically listen to the multicast notifications. And that step on the leg client proxy would require protection. And then we mostly had a lightweight end-to-end related use case where from the transport binding specification, the lightweight end-to-end client can, well, not only talk to the lightweight end-to-end server as part of internal exchanges as usual, but also at the same time use the lightweight end-to-end server as a proxy to talk to an external application server. And that external exchange can also be protected end-to-end with OSCOR. Again, there are more use cases on the draft, but these have always been the main ones. So what we are trying to do here is updating 8613 in order, first of all, to enable the use of OSCORE with endpoints that are not only the application origin endpoints, but in general, any endpoint, including intermediaries, and admitting explicitly, because it will end up being needed, the possible multiple protection of the same message with OSCORE, applying different layer in sequence. And I would expect the most typical case to be 2 protections in a row at most for the same message. But we are not really posing any limit, which interestingly opens for something like OSCORE protected on your forwarding that we started to elaborate as an appendix. And I keep talking about OSCORE here, but you take what is here, and it is just as well applied if group OSCORE is specifically used. Doesn't really make any difference. So what happened since the last version we presented? We added one more very relevant use case related again to Lightweight M2M and proposed by David Navarro. This considers the Lightweight M2M gateway. That in principle allows the Lightweight M2M server to, well, normally access resources at the Lightweight M2M gateway itself, like if it was an origin endpoint, but also to use the Lightweight M2M gateway through proper paths to reach out end devices that are not necessarily Lightweight M2M devices, actually. And in this latter case, the Lightweight M2M gateway is basically acting as a reverse proxy. And the same rationale applies for protecting the different legs with OSCORE. With this in mind, we took the opportunity to revise a bit some terminology, especially for what concerns what we call proxy-related options. We used to have only the first 2 entries. We added a third one, so URI path options present not together with proxy scheme, which is basically what happens if you are trying to perform a sort of reverse proxying. So if you want its terminology, but it's in the interest especially of the use case that David suggested. Yeah, it took some more effort to improve once again the definition that we are giving for co-op options that are originally defined to be class U or I, but that depending on the other OSCORE endpoint for which you are about to protect the message, you have to protect anyway, like if they were defined as class E. So suppose you are applying an ith OSCORE layer using the context shared with another OSCORE endpoint X that has to consume that layer, and that can be an origin server, a proxy, doesn't matter. These options are essentially the OSCORE option, if you already see one as the result of a previously applied layer, the ad hoc option defined in the OSCORE ad hoc document to signal an optimized execution of ad hoc, only if this is not intended for that OSCORE endpoint, otherwise the workflow would just break. And finally, more generally, well, any option that is intended to be consumed at some point by X, but it's not important to be seen already during any processing before decryption or in order to perform the decryption itself. And this is really typically about options for proxies to be protected when you are using OSCORE to protect the message for the proxy. There are more examples than these ones, but I just shown the one we are reporting in the draft. Considering the 2 points put together, we also revisited the message processing, but actually only for the incoming requests, because any other processing is as it was in the first version, basically. Well, for the incoming requests, we required a bit more of engineering, and we were actually able to do some simplification, especially following the improved definition of options to be protected anyway. But we also needed to add an additional sub-step, again, to cover the case of reverse proxying justified by the use case from David. And if you remember from the first versions, this processing was supposed to be about 3 alternatives, A, B, and C, and the endpoint had to choose which one was applying at present. We slightly present now in a different way as 3 steps, including the possible jumping forward or looping back. And it is really about looking at the message you have at your hands right now and deciding, first of all, if that's about proxying or not. If it's about proxying, well, consume the proxy options and forward. Otherwise, it's about consuming the application if the origin application on endpoint has been reached, or decrypting and then actually repeating. Now we have the text for the whole processing in the document. We plan to add at some point an ASCII-based art figure, but until then, in the interest of this meeting, I prefer to prepare something in that spirit anyway. And these are basically the three steps I mentioned that you can distinguish based on the color. And the first step is really about understanding, is this about proxying or not, based on the visible presence of some options about proxying. And it's the only box in light blue. So simplifying things a bit here, if it is about proxying, you get into the light yellow territory, you check the details. Other than error handling, not shown here for simplicity, if you conclude this is indeed about proxying and everything is fine, you forward and you're done. The processing ends. If it's not about proxying, well, you check for the presence of an OSCORE option. If there is none, you are the origin endpoint. You deliver to the application. If there is an OSCORE option other than a corner case for error handling, well, do what the OSCORE option says. Decrypt accordingly, take your result, and start again. So you will eventually end because either you are consuming at your application or because you are forwarding. And in the process, you may end up stripping one or more OSCORE layers. In the backup slides, there's a slightly extended version of this one with more boxes for error handling. Christian.
I'm just looking up at the backup slides, but it doesn't say that there either. I think one important aspect to consider for the document is before forwarding to check whether the sender is authorized to be proxied. And that authorization might typically come from the request not originating just from the network stack on the left, from the white circle, but from having been decrypted from a particular OSCORE context. And that is what authorizes the forwarding.
Absolutely, yes. Probably right now this is too implicit because it was indeed the core motivation from all those use cases. So we'll add it explicitly.
Thanks.
Thank you. Okay, so I hope we can have one day an ASCII-based art along these lines, but this should be helpful already. Right, we added an appendix with a message exchange example. I think the first one is the most relevant one, really, also reported here when you use OSCORE both end-to-end and also between the client and the proxy. We have similar examples, the following two ones, where you basically have the hop-by-hop protection on a different leg, or when you have the protection end-to-end and on both legs. And we have a fourth example also, which is basically like the first one as to where OSCORE is used. But rather than starting from pre-established security contexts, we show how those are established at runtime using ad hoc. So first between client and proxy, and then end-to-end between client and server through the proxy, protecting the leg between client and proxy already with OSCORE. Yeah, we also added a section on cacheability of responses, simply explaining and hopefully convincing that that's possible in this case too, basically using the approach defined in the cacheable OSCORE document that doesn't require any adaptation or extension whatsoever. Here we just need to be careful to clarify which exact message a proxy should really consider as a response to possibly cache, or as a request to use to look for a potential cache hit. And then, as I mentioned before, we added an appendix B that for now is just a list of very raw bullet points, so not really a readable section, but all the raw content should be there. And basically what defined in the document body is a set of building blocks that can be used to build something quite similar to Tor, but using OSCORE instead. I think we need to mature this content quite a bit to make it an actual section in the first place. For later on, we may want actually to consider to extract this content out and to be a separate experimental document, but no rush with that. So yeah, I think I've gone pretty much through everything this document is about. We are not done yet. We have a number of next steps summarized here related to corner cases and guidelines on key establishment. There's an ongoing proposal and open PR in Drupal Score related to improving some handling of responses that I believe will have an impact here too, to extend the handling on the incoming responses consistently also in this case. And we plan to add more examples, in particular for when ad hoc is used with the optimized workflow to establish the context, and at least one example where a reverse proxy is used in the spirit of David's use case. And we've also started to look at the SHIC compression framework, and especially its profile for co-op that covers also the use of OSCORE. If it can be used here, and I think yes, and if it needs some adaptation to be used in a situation where you protect the message multiple times, and I think it needs some adaptation, but we have just started to look into that, and we need more work. Regardless, we think the core mechanics in this version is quite stable, and that's especially thanks to feedback we got all the way, mostly from Joran and Christian, and recently from David. So it's certainly stable for review, and while we work on the next steps, yeah, comments and input are welcome on what we have today. That's it from my side. If there's no more comment and question, and sorry I couldn't follow the chat.
So I'm a little bit curious about this OSCORE, this onion thing. What Christian, there's been some work on this already with Cenk and others. What is the status, and how does that compare to this?
If I may jump in here, the onion work is not so much part of what I did with Cenk. This is mainly a sketch. This is about, hey, we by having all this proxying and having the ability to nest OSCORE, we get just so many properties that that Tor works really hard for, possibly for free, and that's the reason to explore this. It's somewhat related to using proxies to hide yourself, which proxies already do, and nested OSCORE on top of it just gives it proper security properties. But it's mainly exploring how to take things further from, for example, using a proxy as a client to hide your precise address, or registering with a reverse proxy, or with a proxy, say, behind the resource directory, not just to hide your address, so which we do a lot, not to hide our address, but to become reachable. But hiding the address is a side effect, and like if you do this once, it has this side effect once, and if you do it repeatedly, you gain the benefits of onion routing.
Okay, so this is sort of not covering what you've done. This is actually providing some new starting point for continuing that type of experiment. It's not repeating what you've already done, so to speak.
Yes, it's to my knowledge, nobody has really implemented this yet, and this is new and experimental.
Okay, thanks.
Thank you all. And yeah, if there's no more comments, we get into the last item Kopover got. Christian, I don't think you uploaded any slides. Do you want me to share anything from the July meeting?
I didn't upload any slides because I was a bit short in time and then got stuck in a traffic jam. But what I'd like to do is just to yes, I really want to share my screen. So now I just have to. So basically, what I'm screen sharing is really just the notes. but it so happens to be convenient here. Before I get right into the details, summarizing what this is about, I've written a draft about how we could use co-op over GATT, which is Bluetooth Low Energy, which is a way of using Bluetooth Low Energy, or with the profile of Bluetooth Low Energy. The main motivation is that just like web applications in a web browser are typically isolated from the rest of the core network, because the only thing they can do is HTTP requests in WebSockets, and therefore we created co-op over WebSockets to allow applications there to interact with the rest of the co-op world. The same is true for applications on cell phones, and especially on browsers and cell phones, because they might have the physical links. They would need the physical means to establish a link to, say, a co-op enabled sensor that has Bluetooth radio, but the operating system and the browser and basically the whole everything outside the core ecosystem will not make it easy for them to join the IPSP, aka 6LoW over Bluetooth network that might even be existing between several Bluetooth-enabled Bluetooth and co-op devices. So going through GATT is basically an escape hatch for consumer devices for which GATT might be the only way to communicate, if not through the large internet. So this would enable applications such as having a website, maybe even in cache or a local application on your cell phone. You approach a device that is Bluetooth enabled, and you can use all your security contexts like OSCORE, ad hoc, the ACE, the whole stack that you would usually use to connect to that device through some routing infrastructure to interact with that device locally. This has a lot of facets, one of them being addresses, but what I'd like to focus on today is the message sublayer that I think would be suitable for this. If there are any questions, please interrupt me at any time. Yeah. So looking at co-op over UDP, the transport that this is based on is unordered, might have duplications, does not have any state. There is no inherent reliability, and which protocol we're using on top of that is essentially guessed. So we do have the port number, which gives a clue, but you might be running it on other ports, and then things would be different. So what we have as a consequence of those requirements, what we have in there in terms of transport specifics are the version, protecting us against protocol mismatch, the type in order to get all that reliability, the message ID participating in the reliability and in accounting for repetition message loss, and the token for matching requests and responses. Because I didn't mention this here because it's not a difference, but UDP doesn't give us any matching request response, so we use tokens. And then the rest is the rest is basically the tail of a co-op message, as it is in all serializations. Now with GATT, we have a vastly different base. So the communication between the GATT server and the GATT client, or between the Bluetooth central and the Bluetooth peripheral, both of which roles are independent, but I think it makes sense to use the GATT server, the peripheral, which is the constrained device, as the GATT server, and the central as the GATT client, so that the cell phone in the typical scenario initiates the request. That communication is strictly ordered. There is no danger of mistaking a message to be repeated. It is connected, so a loss of connection and a complete reconnect are detected. And there is this very weird situation that we have unidirectional reliability. That means that the GAT client, so the cell phone, can know that this operation completed, and that there are lower layers that will keep retrying. But of course, with the general issues of synchronization and to General's problem, only one of those parties can know, and the constraint device in this setup would not know what whether the operation was successful. And lastly, which protocol is being talked is very clear from the context, because at this connection stage and at the discovery, there is a 16 to 128 bit identifier of the particular Bluetooth profile of the particular characteristic that is being talked about, and this clarifies which protocol we're using. The version that I have published so far as -0 takes a bit of a simplification and works completely without token and completely without token length, using the properties of being ordered and not repeated, and just says, here's the code and the options and the payload. Please process this and send me the response. Limitation is that this only works as long as the roles are aligned. So there is the cell phone that is working as a client and the constraint device working as a server, and as long as all the non-traditional responses that we would be sending are have eventually consistent semantics. This is the case for observations, but this is, for example, not the case if the constraint device were to be used as a multicast proxy. And this might be sounding like an exotic use case, but I think it's a very realistic one, because I'm taking my cell phone to a constrained network of many nodes that are talking Bluetooth IPSP, like my home, my complete home network. I go there, I connect with one of those nodes via GAT, and then the first thing I do is I send out a request to a multicast address, all co-op nodes, through that one distinct node I picked as a proxy, and that one fans it out through the network. I get the response, and I get multiple responses, and this is where the -01 proposal is falling apart. So what I'm working on for -02 is that we do go back to using tokens, and I hope I did get the numbers right, and the most recent one is actually -02, is to actually use tokens and to use those that nibble that is unused in front of that in order to do a very minimal version of the message IDs. In CORE over UDP, our message IDs are 16-bit because we might have a lot of messages in the year. Here, everything is clearly ordered so that synchronization can happen in a matter of basically a 1-bit message ID, and the client it's always acknowledging the one on the peripheral. Yeah, so this that's the rough design. It's deviating a lot from what we have on CORE over UDP, but I think it's saving some things, and it's just making good use of the properties we have on that particular transport, versus trying to force identical behavior when the underlying transport is not behaving identically. And yeah, I think it's a good direction to go, but I would be happy to get some feedback from the group on whether you would do it differently.
I only have the minor comment that next version should be 03.
Okay, thank you. I'll update the things in the minutes.
Any comment or question for Christian?
I'm just curious about the discussions with Marek and their deployment. Is Is there anything to learn from that, or is it they that will need to learn from?
This is using a bit of feedback from Marek, but I have still not seen what they are precisely using, so I cannot. Talks with Marek have stalled a bit, and I have not taken them up. So for a bit of context, for others involved, there are two major companies that are both interested in getting this operational again, EDF and Assa Abloy, and part of getting this forward is due to their involvement. Marek from Assa Abloy is also working on something related, but I don't know precisely where he is.
Okay, if there's no other comments, none in the chat, no one in the queue, we are 1 minute over time with cars that needs to go also. If there's no other business, thank you very much for the great meeting today. Thanks a lot, Richard and Christian, for helping out with the minutes. Talk to you latest in 2 weeks.
Sounds good.
Thanks, Marco. Thanks.
Thank you.
Thank you all. Bye-bye.
Bye-bye.
Bye.